Well, hello YouTube vintage stereo collectors and restorers. This is the last video that I'm doing on the Sansui AU-505. Maybe a review of it down the road once I run it for a while, but as far as the restoration goes, I did a few shorter videos, kind of give you some tidbits and some tips on how to do things. So I'm just going to do an overview of what I've done to fix this, and basically start, well, at the front. Took the faceplate off, cleaned it, cleaned the knobs in just regular dishwashing soap, dried them off, lubed all the with Neutral, cleaned and lubed the controls and the switches, gave these switches a heavy duty cleaning, repaired the phones and microphone jack. They were broken, the plastic jacks were just broken right in half, because I think what happens, people you take off the knobs and then there's 3 screws and you forget to take these nuts off, you pull it off and they just snap. It's usually how they get broken, not in regular use. So I crazy glued them and epoxied them, and so they're nice and tight and everything works there. I'll just show you here. Yeah. Phones just go in there really easily, and it works. So I'm going to talk about different things I did. I did a video on recapping and retransistoring the preamplifier and the phone preamp, a little mod to keep the metal from this phono preamp shield from touching, and then I moved on to the power supply. Power supply is this main cap here. Let's get the original out. Original was a 63 volt 2200, fairly large. This one just was, I adapted a 3300 63 volt to the same holder, just with that dollar store felt. Works really good. It's tight, and then just extended the leads and put eyelets using just 16 gauge wire here, eyelets that you could attach the original leads onto. So that's how I do that part of it. This little power supply, half power supply board and half muting circuit board, recapped and retransistored that. Then I moved on to here, and there were 2 1500 microfarad very oily 63 volt caps, which are replaced with these Nishikon, the brown white ones, which are I believe they're 4,000 hour. Good. It just seemed to be a good choice for that. Much smaller, of course, because time has changed the way capacitors are made. But interestingly, I opened up the other cap like this, and that's what was in it, which is about the size of that. There's quite a bit of tar and air inside that, and it's very dry, very dry. It still worked, but it had leakage. If, like say, if you're going to only replace a few, the speaker coupling caps are really important, and then the rest of the caps. I also replaced the fuse holders in the B+ line, one for the left channel, one for the right channel, because one of them had a very loose rivet that was causing an intermittent. Now on this board in particular, almost all the transistors had black lead disease and some noise, and not one of them was what's on the Sansui schematic. They're all different, and I believe they are original, but they're factory substitutions, that were changed in production. But I was having coffee with a friend of mine who's also a tech, and I just said, when you're repairing these, the biggest problem with an aging Sansui is noisy transistors. And he said, yeah, exactly right. It used to be it was the caps, and now the transistors are as big factors as the caps. So I'm just going to go through them. There's 2 PNPs. The first transistor in the circuit, they weren't even what was supposed to be in there. There's something else. A7 something, it's kind of rubbed off. I used 2 N3906s because the collective voltage is only about 17 volts in that circuit, so no problem there. And a few of the caps are really off value compared to the schematic, and they look like they've been replaced. These two were blue Nishikans, but everything else was Elna, and the soldering was really lumpy, so I think they've been replaced. And there are 330s, but the factory schematic calls for 470. Probably didn't make a big difference, but I put it back to 470 and used Nishikans there because I didn't have the German ones. These had 33s, also replaced with the blue Nishikan, which is about a late 80s cap. Put 47s as per the schematic. And then one little tiny mod here. There's 1 microfarads, which is the first cap onto that board coming from the preamp. They were 1 microfarads from the factory, and I found through trial and error that a 4.7 is a better cap there. It just makes a little improvement in the bass. If you're going to replace one of the caps that are in the preamp circuit, it's these two right here. C805, and what's the other one? Sorry, that letter is really small. C805 and C806, yeah. Another one to upgrade, the 75 volt cap that people talk about on forums. There's one 75 volt capacitor, and it's 100 microfarad, and it's the soft start for the output circuit. It just basically lets collective voltage build up slowly, not blow up. And I made this at 220, and because I couldn't find a 75 volt cap anymore, I found a 250. So you've got, this thing's going to last because it has the voltage range. Kind of hard to get some of these voltage values and that were available in the 70s are a little harder to get now. Like 1500s, it's much easier to go up to 2200. 220s, yes, a 220 microfarad is very common, but a 75 volt not so common. 63 to 100 to 200. But this 220, that allows it just a little more time to build up. So there's absolutely no thump on turn on, nothing. Then I moved on. These two had been replaced. They're NPN circuits, but they basically do, they set the center voltage through this control, the center voltage between the two NPN output transistors, because it's a single rail power supply. Somebody had the good idea to put in metal transistors. The little pots were this one was one of the better ones. This one turned, but the value didn't change. It was a 1K pot, and it just stayed at 1K no matter what you set it to. Just, it wasn't making good contact. These, just like the black lead disease on the transistors, once it gets into the pot, it's hopeless. You can spray it, and it might be okay, the bias, until you touch it. Then it gets shaky. These burn ones are very widely available and very reasonable, and they're sealed, so a 1K and a 1K in the same original position. And I think what I might do, I'll put a C and a B, get a marker. This is center voltage, this is base voltage, or bias. Then I moved on. These are the drivers. So a PNP and NPN, a Suzuki pair that drive these outputs. And I upgraded them. What was in here wasn't what was on the schematic. An A667, what was the other one? A667, C1211, there's something else on the schematic. Similar specs, right? But one of the problems I've noticed over the years, if one of these blow, in this driver circuit for the outputs, it can take out the driver, or it can take out the outputs as well, because it will then send voltage straight through at the wrong level. But I've noticed, like when I've done like a forensic audit on something that's blown, you have a transistor blown here, one or two of these will be blown, maybe the next one back here will be blown. Kind of like a domino. It should blow the fuses, I know. It should burn up the emitter resistors, I know. Oh, I just dropped my headphones on my foot. These old ones are heavy. So anyway, finish the recapping, new bias pots, and I haven't turned it on yet. And I'll list some of the values that I use as substitutions, but 2N2219 is the NPN driver, and its running mate, the PNP, is 2N2905A. Those are, they're supposed to be the complementary transistors, and they can dissipate a bit of heat. And you know what's interesting about this circuit? It is almost identical to a Kenwood KA2500, which was a little earlier than this, 68 to 71. But the whole, if you look at the schematics and compare them, they are so close it's not even funny. They're even the same value of pot. So 20K, 20K, 1K, 1K. Resistors, a lot of the transistors are the same. Number of stages are the same. The emitter resistors are the same values. The power supply is set up the same except for this muting circuit. The phono preamp is at 2 transistors per channel for the magnetic preamp. So I'm going to plug this in and turn it on. Get my hand on the power cord. There it is. Now, one little tip to give you when you're changing bias and center volt pots, when you get the old one out, measure it, see if you can get a measurement as to where it was set, especially if it was working in the right range. I could get on the center voltage, they're set around 5K, so about the middle, so that wasn't a big deal. The bias were about 700 ohms. That just makes it easier so when you turn on it doesn't go into thermal overdrive. So what I'm going to do is set up a meter here, cross an emitter resistor, like that, like that. I usually don't do this with speakers hooked up because I don't want, the full voltage that's in the output circuit going through to the speakers if for some reason it does. Just go over this emitter resistor. So they're both in the 2 volt scale. And I'm going to put on the headphones and see what I get. Smoke show. Well, I've got sound. I have sound both channels. It's certainly not ramping up the bias. So let's take up this one. Because I changed so many parts, there's going to be, things could be quite a bit out of whack. So let's go up. Let's find center voltage. I'm not sure if it's this one or the other one. That's going to be the other one. That's hard to clip on to. Hang on. I want to make sure I'm not shorting these out. Okay. So 28.6. The rail is around 59. It's actually not far off. But let's just make sure the controls work. So this is the center voltage for that channel. Yeah, so let's just bring it up to 29 like that. Just as a starting point. And this one, gotta get onto it. Wow, it's close. So it was fairly close. Just about 29, okay. So it's not going to be far off from there. And we just carefully go back here, get back onto that. There's another way you can do this too. You can go over the fuse holders as well. So we have about 2.4 millivolts. I haven't even looked in the what it's supposed to be, but I think it's around 14. But we do know that bias is being applied. So very carefully bring it up to about 5. We'll let it warm up. If you notice what will happen, you adjust one channel and the other one changes. Yeah, I actually did some looking, and the actual factory service manual does not show what to set the bias at or the center voltage, but there are a lot of other things on forums. In the past, I've set these between 10 millivolts and 15 millivolts across each resistor, and that seems about right, and that's based on the transistor configuration in many other amps. This Suzuki pair and quasi-complementary NPN configuration works good in that range. As you can see, as it's warming up, we're coming up to nearly 10 here, and we started at 5. So how's it sound? Don't want to get a copyright strike, but it is working. I'm just playing it through some minimus 7s that one's kind of pointing that way and one's kind of pointing that way, but nothing's overheating. Everything's cool. Even these. And maybe a tiny bit warm because at lower volumes, it's those transistors driving everything. So basically on the transistor front here, the output transistors are original, but the grease has been changed. The driver set has been changed. The pre-driver was changed in the past. It's a really good transistor. And everything back from that has been changed out. I did not change this one. This is the soft start. It's a 60 volt transistor, and I actually put a 2N22 in there, and it didn't work properly. But this does not have black leads on it, so I'm reusing that one. It doesn't serve like any sonic purpose except to bringing the amplifier up slowly. The best thing now is to run it I'm going to run it most of the afternoon and just make sure the adjustments are solid. We can even go back, now that it's been running a few minutes, and check the center voltage. Now there's 2 ways to set center voltage. The easy way and the hard way. The hard way is to actually use a scope and to drive it into a dummy load to full power, wait for it to clip, which could wreck something, and then adjust it from there so that clipping is even in the positive swing waveform and the negative swing waveform. But the easiest way, and this I've just been doing this way a long time, you look at there's the rail at rest warmed up, 59. I think I'd go up to almost 30 volts on this side. Maybe 29.5, let's go there. That's going to affect the bias, but it will have more linear crossover. I can do this. Hard to get a screwdriver in that little slot. Very hard. So 29.5 approximately. Yeah. So, let's see what it is on the other side. 28.8. Bring it up. Now, when you bring it up, it's going to bring the rail voltage down because it's not a regulated power supply. This one's trickier. There's a little burr there. Bring it back a bit. A little bit more. Come on. 29.5 there. So that gives us and then let's look at the rail. See, it's Let's come down just a hair. So what's half of that? 25 plus 4.6. 29.6, about 29.5. See where I'm going here? Basically what you're doing is setting the center point, which is your negative, of a single rail power supply, and then one transistor operates above that and one operates below it. And so you get when you get a sine wave through, each half gets equally amplified. Now this is going to throw out our bias a little bit. It came down there. Let's put the bias back on here. And you know, the worst thing you can do is when you're doing this setup after all that soldering and changing stuff, is to have something short out. I'll be really careful clipping on. This one's got lots of room, so I'm not too worried. Yeah, so 9.2. So let's bring it up to, let's say, about 12. I'm going the wrong direction. So I'm turning the 1K pod in the circuit. And this is going to float around quite a bit, because if somebody's air conditioner kicks on next door and we're on the same power transformer in the street, it will drop the voltage a bit. Here over 12. Yeah, there we go. So there you're about 12.2, and that's going to come up a bit. I'm aiming for between 10 and 15, so about 12 and a half. And let's see what it sounds like. It's clear, very clean sounding unit. Of course, the bias is going to jump up as these turn on. And what's interesting is these are not going to turn on until about 2/3 of the volume control. It's surprising how much of the workload that those pairs do. And it actually, so then you're basically like, at your lower level settings, you're in class AB. And then you're in B1 after that. That's how it was explained to me 100 years ago. Yeah, so I'm just going to let this run, and we'll put the music on and play this afternoon, just see how right. It seems to be really quiet. I mean, this thing, these Sansuis, just like Kenwoods and Yamahas, when you've done this kind of work to them, it's going to be a real treat to use. This was a kind of a scratchy, noisy unit until I rebuilt it. And now you've got reliable stuff in it. Once it's burned in, it should go a long time. This is like its half-life restoration. Anyway, thanks for watching and listening.